Today I will talk about Hamming codes. In this problem, we just need to use a loop to go through all of the possible integers, convert them into bit sets, and then compare which ones have at least a Hamming distance of d. So here in my code, I created this vector list, which will be our answer. So here I went from 1 all the way to the maximum integer value, but it isn't necessary to go that high, but I used the maximum number so we can test all the possible cases. So if we're ready, just C is the number of answers that we found. So we already start with one number, and that is 0. So if the number of answers that we have is already equal to n, then we can stop this loop and then we can print out the answer. Otherwise, we create this small loop inside, and in this nested loop, we will use this distance function, which will calculate the Hamming distance. So after receiving two integers, this will find the bit set value of a XOR b, and this basically finds all the values that are different, which is how they find the Hamming distance. So they'll find all the bits that are different, convert this into a bit, and then using this d integer, which is start at 0, and if a value at this bit set is 1, which means that they have this value at a and this value at b have two different numbers, then we can add 1 to this d and we'll return this d. So if this lowercase d is smaller than the capital D, then we'll stop this because we want it to be bigger than or equal to this capital D. And if it is bigger than or equal to the capital D and all the previous values in our answer vector also have at least a Hamming distance of d, then we add 1 to this counting value, and then we push I into the answer vector. And then it will just keep on going until it finds the amount that it needs, and afterwards we can print out all the answers, and also it says that you print 10 numbers per line. So I added this to print a new line every 10 numbers, and that's it for this question.